So I wanted to actually add some fractions together with you guys to begin with today. The first, what we're going to add are these two fractions, 1 over x minus 1 plus x minus 2 over x minus 1 squared, and then 2 over x minus 1 minus 1 over x minus 1 squared. Or I'll put the minus up there. So we're going to add these two fractions together, both of them. How do we add our fractions together? Common denominator. What is my common denominator? X minus 1 quantity squared. So this would be an x minus 1 over x minus 1 times, so 1 over x minus 1. So that gives me an x minus 1 in the numerator from the first fraction, and nothing from the second. It's already got the common denominator. When I simplify this, I get a 2x minus 3 over x minus 1 squared. Okay? Now, let's do the second one. Here again, what is my common denominator? X minus 1 squared. And I have to multiply on the first one again. I just chose to write it in that order. We get a 2x minus 2 in the numerator of the first fraction, plus our minus 1. What is that equal to? 2x minus 3. Now, suppose that I had given you the 2x minus 3 and I wanted you to give me these fractions. What two fractions got added together to give me 2x minus 3? That's our goal. Okay? It's not a unique decomposition. You can break these up in numerous different ways and you'll get two fractions or three fractions or four fractions that you could add together to get that final answer. However, you have to be very careful which method you choose to do this in to make the integrals the easiest. And so the guidelines that I have given you break it down into fractions that are easy to integrate. That's why we use these guidelines. So let's look at these guidelines. I'll come back to the derivation in a second. Our guidelines are divide when you have an improper fraction. What is an improper fraction? Yeah, degree of the numerator is higher than the degree of the denominator. Numerator. I don't think I can spell numerator and talk at the same time. And in fact, I'm going to say greater than or equal to. If it's equal to, you still want to break it up. Then factor the denominator completely. That's going to be your second step. After you've done your long division, factor the denominator completely. Do not factor the numerator, only factor your denominator. If you have linear factors of the form px plus q raised to some power, it's linear inside right here. X does not have a power on it, so you have px plus q raised to some power out here. Then you have to have the series of fractions here of value. We're going to call it a or b or c. I'm going to use the alphabet. Over px plus q, something over px plus q squared, all the way up to something over px plus q to the power that you have in your factored expression. You have to represent all possible powers there. Let's go back and see why. And then we'll talk about the let's talk about the quadratic. I can motivate this one real easily by my example, but we'll do that in a second. The quadratic one. Notice that your values that you're putting in the numerator of the fraction are something times x plus a constant. It has to be one power less than what you have in the denominator. So if this was a cubed, you'd have an ax squared plus a bx plus a c kind of thing in your numerator. has to be 1 degree less than what's inside your powers in your denominator. So not this power outside, not 1 degree less than the outside power, but 1 degree less than the inside power. Question? You're going to solve for them. Yeah, we're going to have, yes, we're going to have many systems of equations to solve. Yes. Okay, so let's go back and let me show you why. If we go back to my example that I did right here, notice something that I have. I have a degree 2 polynomial as one of the things, and I have a degree 1 polynomial in both of the examples where I broke it down. But if I look at this fraction amount here, it starts with just the degree 2 polynomial. That's because when you got the common denominator, it swallowed up the degree 1 polynomial. You have to represent all possible degrees there. Some of your answers will be 0 for the numerators. That's okay. That makes us happy because that's less to integrate later. But you have to give it the entire option of having all those possibilities. So you have to give it that option. The same thing happens when you have 3rd degree polynomials and stuff like that. Does that make sense? I think that's the derivation we're going to use. I'm not going to go and derive the process. Let's do a bunch of examples. Give the form of the partial fraction decomposition of this fraction right here. What is the degree of the numerator? 3. What is the degree of the denominator? So this would be an x cubed here. That's an x to the 4th, and that would be an x. Yep. So looking at that, is this an improper fraction? No. So I don't have to worry about that first step. What does the second step on your sheet say? Factor the denominator. Is my denominator factored? Yeah, I factored it. You can't factor it any more than that. So now I just break it down into the forms. When I do that, I write the entire original fraction. And now I have to have something over the linear term x. I'm going to call it an a. And then I have to have something over the linear terms x minus 1. But what is the first power of x minus 1 that we're going to have? 1. So I need an x minus 1. Then I need something over x minus 1 squared. And then something over x minus 1 cubed, because it goes up to the cube on the power. So I have to represent all the fractions up to that power. Now let's look at the second one. I have those quadratic terms. I'll come back and put in the numerator in just a second. For the quadratic terms here, I have to have an x squared plus 4 and then x squared plus 4 squared. Do I need to go higher than that power? No, you just represent up until your power that you have, so x squared, and then I stop. Now let's go back and fill in the numerators. You're always going to have one power less than your denominator. So the denominator of the degree of the denominator for x is 1, so you just have a constant here, no x variable. Here the degree is 1, so what do you think we'd have in the numerator? Constant. So I'm just going to call it b. Oh, can't write in yellow. Call it b. What do you think we need over x minus 1? The degree inside the parentheses is still 1. C. And then d. Don't get this confused with the degree outside the parentheses. I'm looking directly at the x here, not at the power outside, just at the x itself. Okay. Now for the quadratic, what what's my degree here? 2. So that means I need a degree 1. So I need something with an x term in it. I've used d, so this would be ex plus f. And the degree on this one, look at what's the degree of the x, and our degree here is 2. So I need something again that has that x squared, that has an x term in it. So it's going to be gx plus h. That is the form you have to represent it in. Question?
I'm a bit confused. How were you? Why did you put the denominators in a certain power, and where did that come from?
Okay, so I think this is what you're asking me. How come I have b is x minus 1 and x minus 1 squared? Because I have to represent every power up to that cubic, including that cubic. Because when you get your common denominator to add them together, you would have changed the denominator up into that power.
Oh.
Yeah, so fractions that could have a smaller power are also included in there, but you've changed their denominator to have that power. So that's what's happening. Question?
Why did you represent the constant with the ex plus f without the constant in the b minus something?
So this one has the x in it, but this one does not? Is that the question?
No, the constant x squared plus 4, you represented the 4 with the number, but in the ones above with the x minus 1, you didn't.
That's an H.
It's not
This
more,
is
it's
an
H.
H, not a number.
No, I know.
But you don't ever put any numbers in your numerators. You
Yeah.
solve for them.
I'm talking about the A, B, C, D numerators up top.
Why don't they have another constant?
Yeah, like x minus 1.
Because there's no x degree. There's no x variable up here. This has an ex plus f.
Why does f get a number and like the 1 up top of it?
This f has nothing to do with that 4. It has everything to do with the fact that that's a power 2. And you have to give the whole polynomial starting 1 degree smaller. So if that had been a power 3, I would have an ex squared plus fx plus g. Yeah. Does that make sense? You're not worried about the numbers. You're only worried about the degree of the polynomial there. And so then you have to represent the entire polynomial. And you never put any numbers in these in your numerators when you're writing them. You just use letters. Question?
So why is it ex plus f instead of just e?
Because you have an x squared in the denominator, so you have to have an x term in the numerator, but you also have to allow the possibility that it was only a number, so you have to give it a constant also.
What?
You have to give it all possibilities.
So because it's x minus 1,
Has nothing to do with that.
that's why you don't have another. It's not
Yeah,
like
it's because it's the x.
Okay.
The degree on x is 1, so you don't
Okay,
put
the
an x in
inside
the
of the-
numerator. Yeah, it's
Okay.
inside the parentheses, not outside of it.
Alright.
Question?
So is the A over X referring to just that first X out?
Yes.
Okay.
Any other questions on that? Question?
There's like x cubed in the denominator, and then ex squared plus f.
I'm not going to give you one like that. Yeah. Okay, I'm not going to solve this for the constants. I'm going to solve a much shorter one for the constants, but you can actually solve these for the constants by getting your common denominators, grouping your terms together for the powers of x that you have, and then setting them equal. But I'm going to show you that on a much simpler problem than this one. But this one showed you how to write it in all possibilities that you would have on your homework. I'm not going to give you degree 3 polynomials because those are very long to solve for partial fraction decomposition. It's going to be degree 2 or less. So let's look at this one. Give the form of the partial fraction decomposition. What is the degree of the numerator? 3. What's the degree of the denominator? 2. What does this mean we have to do? Long division. For some of you, that was a long time ago. how many times does x squared go into 2x cubed? How about a 2x times? So multiply, I get my 2x squared minus, 2x cubed minus 8x squared and minus 64x. And then we subtract. Those cancel, and this becomes a plus 64 minus a 63, which gives me an x. Bring down your 46. How many times does x squared go into x? It can't. The degree's small. So then this becomes 2x plus x plus 46 over x squared minus 4x minus 32. What is the next step? That was our first step on our guidelines. What's our next step? Factor the denominator. So we get 2x plus x plus 46 over, what is that? X minus 8 plus 4, that sounds right. And so then if I'm writing this down, I am going to actually have, I'm going to draw an arrow. It's going to go right here. 2x plus, I have to have something over the x minus 8 and something over the x plus 4. What should we put into the x minus 8, over the x minus 8? A. What goes in over x plus 4? B. There's our partial fraction decomposition. If we wanted to solve for this, we could do so. I'm not going to do that. I'm going to do that on a different problem. Do you guys understand how to do the decomposition, how to write it in the fraction forms? If you can't do that, you can't do the homework today. That's where it all starts. Okay, so let's actually evaluate an integral then. Well, that's the whole point. This is not something you would do a trig substitution with. It'd be really hairy. You could multiply it out and do your best to do some form of completing the square for the denominator and then possibly do a trig substitution on it. But here again, it's still not going to be something very fun. So that's why we need partial fraction decomposition, because we can integrate a single fraction using our arctangent rules or our natural log rules, so 1 over x. So those end up being simple integrals. So what is the degree of the numerator? What is the degree of the denominator? 4. So that means I don't have to do long division. So we have 2x cubed plus x squared plus 16x minus 4 all over x times x minus 1, x squared plus 4. I have to break this up. We're going to have our x fraction. We have our x minus 1 fraction and an x squared plus 4. Notice that I don't have any higher degree fractions for the x squared plus 4 because there is no power outside. So I only need one fraction for it. If I had a power of 2, I would need 2 fractions. If I have a power of 3, I need 3 fractions. But there's no power on the outside. So those are the fractions that I need. What goes in the numerator of the x fraction? How about the next fraction? B. And the last one? Cx plus d. All right. Now, what we're going to do is we're going to get a common denominator for the right-hand side and add it all together. What is the common denominator? Yeah, it's exactly what the original fraction had for the denominator. What do I need to multiply the first fraction by to get that denominator? Question? Yes. Yeah, and it should be, and we should recognize it to be that way. What do I need to multiply the first one by? X minus 1. Wrote too many parentheses. x squared plus 4. What do I need to multiply b by? X times x squared plus 4. And then the last one? X times x minus 1. So if I multiply the a times, well, let me write it out. I'm going to have a times x cubed minus an x squared plus a 4x minus a 4. And then I'll take the a through in a minute. And then we'll have b times x cubed plus 4x. And then we'll have cx plus d times x squared minus x. Now, let's continue. If I multiply the a through, I'm going to get an ax cubed. I'm going to keep this in the brown ink because this is still scratch work. Ax cubed minus ax squared plus 4ax minus 4a plus bx cubed plus 4bx plus cx cubed plus dx squared minus cx squared and minus d times x. All divided by, don't multiply your denominator. Now group this together in terms of x cubed. What do you have times the x cubed? We have an a plus a b plus a c. Those are the x cubed terms. What do we have times the x squared? Negative a. Yes, plus a d minus a c. And that's everything. What do we have times the x terms? 4a, 4b, and minus d. And then the last term is going to be minus a 4a. All of that divided by x times x minus 1 times x squared plus 4. Now, what I'm going to show you, if you are reading the book, and this drives me crazy that Larson actually does this, because there's no need to have two different methods for this, when one method will work no matter what. The second method works all the time. The first method will not work if you have a quadratic term. So you're going to try the first method because it looks easy, but it doesn't work when you have a quadratic term. Don't pick numbers and plug them in for x. It's not going to work with a quadratic term. X squared in the denominator. If it doesn't, with the linear terms it works, but it doesn't work with the quadratic term. The quadratic term squares it, you lose your signs. Yep. So, watch this. This will always work. Let me get another piece of paper. This method will always work. What I'm going to do is I'm going to equate the two numerators. Polynomials are unique. To have these two polynomial fractions, these two rational functions equal to each other, the coefficients have to be the same. So equate the coefficients. So in this case, the coefficients of the numerators is the only difference. That means that what do I need for the coefficient? What is the coefficient in front of the x cubed term on the left-hand side? What number is there? 2. So I'm going to have 2 has to be equal to a plus b plus c. It has to be equal to all of this right here. Whatever is multiplying x cubed has to be the same on both sides of the equal sign. That is given to us. mathematicians are inherently lazy. So we don't rewrite everything on one side of the equal sign. If it's the same thing over and over, we don't write it down but once. This equal sign says all of these things are all equal to that original one. So, looking at the x squared term up there, what is the coefficient for the x squared term? What should this term right here be? 1. So this part equals 1. How about the x term? What should that be equal to? 16. And how about the last term? That should be the minus 4, right? So you equate your coefficients. That means that down here, I'm going to have, I wanted that pen. I'm going to have 1 is equal to minus a plus d minus c, and I'm going to have 16 is equal to 4a plus b minus d, and 4 minus 4 is going to be equal to minus 4a. And we solve these. You guys remember, question? Wasn't it a 16? Can I not read my own writing? It is a 16.
Yeah.
Yeah, that's a 16. Question?
When you wrote it down below, so you can't see now, but before it has B, you didn't write before it has B down, like, lower.
Oh, the 4b for the x.
Yeah, 4B minus B.
Okay, yes, I missed that. I missed it. Thanks for catching that now and not 10 minutes from now. That would be when I'm done solving the system. And I have to explain my steps. It takes a while. If I'm just doing it myself, it doesn't take as long. You guys will also be faster than I do it because I have to make sure everybody's following. Okay, so here are my 4 equations. You guys remember from pre-calculus, we have 2 methods of solving these. You can do substitution or you can do elimination. It's your choice, whichever method you want to use. I am going to use substitution today. That's the method I'm going to choose. I start with the easiest equation. I have a minus 4 equals a minus 4a. What does that tell you a is equal to? 1. I'm going to go and plug it into all the other a's that I have. So then I'm going to have 2 is equal to 1 plus b plus c. 1 is equal to minus 1 plus d minus c. And 16 is equal to 4 plus 4b minus d. I plugged in a equals to 1 into all the other a's, and now the a's are all gone. Okay?
No, I just meant to say.
You got it?
No, I got it.
Okay, we're good. Now, I have these constants over here, so let's subtract them, get our constants on the same side, and that means that we're going to have 1 is equal to b plus c. Over here, if I add the 1 over, I get 2 is equal to d minus c. And over here, I need to subtract my minus 4. And what do you get? 16 minus 4, 12. 4b minus d. Now I've got that fairly simplified. So I'm going to choose an equation, any one of them, it doesn't matter, and solve for a variable. Which equation would you like to choose to solve, and which variable do you want to solve for? The second one? And you want to solve for c? Okay, so if I solve for I'm going to solve for d. It'll make it. Oh, okay. Let's solve for d. If I solve for d, then I have to add c to this side. And we get d is equal to c plus 2. Okay? D is equal to c plus 2. And now I can take that and I'm going to put it into this equation right here, and I will get that down to a variable that just has b and c in it, and this one just has b and c in it. I'll use those two equations to get an answer. So I'm going to have 12 is equal to 4b minus c plus 2. So what should we do with that minus 2? Add it. And I have 14 is equal to 4b minus c. Now I have an equation right here that just has b and c in it, and an equation that just has b and c in it. So I can solve one of them for c or one of them for b and plug it into the other equation. Which one do you want to choose? The second equation, add the c over, is that what I heard? So we have 4b is equal to 14 plus c. Let's divide by our 4. Change that ink color. And you're going to have b is equal to 14 over 4 plus c over 4. Those are 4s. Now I'm going to take that and plug it in over here for b. So I have 1 is equal to 14 over 4 plus c over 4 plus c. Do we like fractions? Hey, some of you do like fractions. Most people don't. So how do you get rid of the fractions? Multiply everything by 4. So that's exactly what I'm going to do because I don't happen to like fractions very well. So that means 4, I can write this in blue ink. 4 is equal to 14 plus c plus 4c. So how many c's do we have? Solve that for c. Our final answer might have fractions in it. What is 14 minus 4? Negative 10. Divide by 5. Oh, I forgot to write this in brown ink. And so then divide by 5, and we get, what is c going to be equal to? Yeah. C is negative 2. Now we can go back and plug it in for b. And yeah, you can find, okay, you want to get d first? Plug c equals to 2 in for d. So you have d is equal to negative 2 plus 2. B equals to 0. And now we can go back and find our b. B is equal to 14 over 4. Actually, I'm going to go back and use an easier version. 14 equals to 4b minus c. C is a minus 2. So then that means 14 is equal to 2 plus 4b. Subtract your 2. Yeah, 12 is equal to 4b. What is b equal to? B equals to 3. Okay. Now, let me get another piece of paper. I was scrolling it back up. I have all of these constants. We have b equals to 3. We have d equals to 0. I have c equals to negative 2. And someplace we had an a equals to 1. So that means that we can integrate it now.
Oh, what? Oh, gosh, I forgot about this.
Yeah, we have to integrate it yet. So it's a over x. Oh, let me show you. You have a over x Oh, that's not gonna work. A over x plus b over, what was our second term? X minus 1 plus cx plus d over x squared plus 4, I believe. And your homework, I think 6 or 7. They aren't all integrate. Only some of them are integrate. So a then was our 1. That becomes an integral 1 over x dx plus the integral b. B was 3. 3 over x minus 1 plus the integral c is a negative 2. D is 0 over x squared plus 4 dx. Now, what's the integral of 1 over x? Natural log. Natural log of the absolute value of x. What's the integral of 1 over x minus 1? Yeah, natural log of x minus 1. Now this one I'm just going to write as minus 2x over x squared plus 4. Can I take that minus out in front? How do you integrate that last one? U substitution. So u equals to x squared plus 4. Du is equal to 2x dx. I have a 2x dx, so happily I chose numbers well for this problem. What is integral of du over u? Natural log of u. And now back substitute for u, and then we are done with that problem. I said we were done yesterday in the middle of statistics class, and I guess I was on Wednesday, and everybody started packing up to leave. We're done with that problem. I still had 3 more to go. You can't integrate the original equation the way it was. The only steps you could do is trig substitution, is a partial fraction decomposition. That was our original form. I just plugged it into the original form. Too far. There's our original form, right there. And that's where that came from. Question?
Okay, so on the test, are you going to specify which method you can use to integrate?
I will give you questions on the test that you can only integrate in those specific methods. But then you have to figure out which method to use. Yes, so no, I'm not going to be specifying that for you. Sorry about that. Okay, I did one that was extremely difficult to show you all the process because I knew I'd only have one chance to do one example today. So now you guys get to do one that is actually really easy. It took me 4 steps to do this one. I mean 4 lines to do this one. This one is not hard. So make sure you write your names on your papers though. I don't want you to use U substitution. I want the process for this one. Do not use U substitution. Do this one by tricks, by partial fractions. I can give you a harder one. I set it up to be easy, which means that yes, you can use U substitution.
I know exactly.
for it to be an x, this first one has to be x squared. This term is x squared. This first bracket is back to the x term is x squared. So we'll not do the biggest degree.
Oh my goodness. Wait, what?
Let me get my pencil.
I am so confused. More or less it is. Wait, no. Oh.
Okay, so this one, when you're getting your common denominator, you also have to multiply it. So now that ax plus a. Now you have to group, you're gonna have a, and then a plus b. So then we started with just this x right here, that a has to be 2. And a plus b has to be 2. Just write plug it into your fractions. You have the integral of 1 minus 1. Yeah, and then you integrate.
Plus.
Read their minds.
How would you figure out the island for zero? Okay, so. Yeah, right. Yeah. So what happens zero? Is two go up by somebody all AX. So everyone. I mean, like, integrate
I'm so sorry.
Because you know what you want. You know that it makes sense, so it's wrong. That's fine. I never thought about it. I'm not sure if it's actually. But the thing is, so the thing is, that everything you have to use.
Make sure your names are on your papers, guys, as you're turning them in.
That is the one drawback.
Make sure that can't happen again.
Are you going to see? What? Are you going to something? No, we're gonna call. All right.
Oh yeah, aren't you going to that?
Hi, Courtney.
Ready for the weekend. How about you? Oh, you said that.
I don't really want to.
Are you only going to
Yeah.
Oh. Just.
No, Korean church has their own language.
Oh, okay.
So I'll help them with that.
Don't be late.
Were you?
Yeah. One over next.
I know, I kind of want
Yeah. That was so confusing. One over that.
That's actually pretty dope. Sure, we get Oh, okay, Kevin. So, do you substitution?
That's why I got that.
So write this as x plus 1 is negative 2 for sure. And then do 3 equals x plus 1 with the substitution. And then take du dx.
Is it like his real story?
So what is it? Plus or minus?
Waiting for appointment.
Plus, because u to the negative 1, when you do the antiderivative, you do it, and then you put this on the denominator, right? So since it's minus, yeah, exactly. He used to be computer science.
Did you really?
Yeah.
He's a trader.
What'd you change to?
Biology pre-med.
Hey.
I couldn't take
He's
it.
following the stereotype.
I like calculus.
He's following the stereotype.
Well.
Oh, I'll follow the stereotype.
That's amazing.
I do. Yeah. Also, because I thought chem major needed it, but I'm not a chem major. Just
I did one of my wisdom teeth are growing in and
Wait,
I
have they
was
done
annoying.
part one?
yeah.
Then why am I here?
Because you like math. Math is fun.
I need a 3
It'll actually do you well in your major because you have to do, your senior year, you do some stuff with partial differential equations, stuff like that. And that is very useful to have the calculus you have.
I
Okay.
just think you get the upper hand if you do calculus.
Yeah, you do.
You go in calculus for computer science?
Yes, you do.
Get out of here.
What?
I don't know, man. Currently, I'm going to be in a math class.
You know you like math classes.